All right, here we go with the trigonometry test review that I promised you. Remember, the retake for this test you have up until Friday of this week. So the first couple questions, all I'm asking you for is the ratio. So if I have a 12, 35, 37, that's a right triangle, and I want the sine of angle A, the sine would be the opposite side 12 over the hypotenuse, which in this case is 37. So it's just 12 over 37. The tangent of C, I have to look at the other angle. So C, the tangent is the opposite over the adjacent. So when I look at angle C, it's a different angle than A. So the opposite now is 35, the adjacent is 12, so the tangent of C is just 35 over 12. Same thing on problem number 2, but I have to figure out what that third side is. Luckily, I remember that it's an 8, 15, 17 Pythagorean triple. So that means I need to find the cosine of Q. Well, the cosine is the adjacent over the hypotenuse, so that would be 8 over 17. And then the tangent of R would be the opposite side, 8, over the adjacent side, 15. And then I should always reduce those if I possibly can. Question number 3 is the exact same idea, but you have to draw this triangle for yourself. So if it says the sine of x is 5 over 8, I just draw any random right triangle and I put angle x over here. Doesn't matter where you put it. It's got to be a right triangle because it's got a sine, cosine, and a tangent. So the sine will be the opposite side over the hypotenuse, so that tells me that those two sides are 5 and 8. Well, what I need to know is this third side. So I'm going to do a Pythagorean theorem. 5 squared plus question mark squared equals 8 squared. So 25 plus question mark squared equals 64. So I have to subtract the 25 to the other side. So I get the question mark squared is 39. So that question mark side is the square root of 39 when I square root both sides. So now I'm going to do the cosine and tangent just like I always do, where the cosine would be the adjacent side, that square root of 39, over the hypotenuse of 8. Nothing to reduce there or simplify down. And then the tangent of x is where I have to do a little bit more simplifying, because the tangent is going to be the opposite side 5 over the adjacent side, which is the square root of 39. But I can't leave the square root of 39 on the denominator of a fraction, so I have to multiply the bottom by square root of 39, also multiply the top by the square root of 39, and I end up getting 5 root 39 over 39. And that would be the tangent of that angle x. So that's what I'm looking for on the first few problems on the test. From there, I want you to be able to solve for any missing variable that I give you. So let's look at problem number 4. I give you a 31-degree angle here. It is attached to the adjacent side, and across from the 90 is always the hypotenuse. So I'm looking at the cosine of that angle should equal that ratio of x over the hypotenuse of 15. Now remember, if you type in the cosine of 31 on your calculator, you're going to get a number. In this case, I get 0.8571, and that should equal x over 15. I usually only go to 4 decimal places. That's enough to avoid making an error with rounding. I like to think of this as a ratio over 1 because then I can cross multiply. X times 1 is x. So what I need to know is, what is 0.8571 multiplied by 15, because that's the other multiplication. So that's what I'm going to multiply by 15, and I end up getting 12.9 when I round to 1 decimal place. And that's where we're going to round on all of these, is to 1 decimal place. On the next one, you'll notice this one does not have a 90-degree angle. So if this does not have a 90-degree angle, I'm forced to use, wait, this one should have a 90-degree angle, sorry. This one also should have a 90-degree angle, so now I need to figure out what relationship I'm looking at. So 51 is across from the 8, so that's my opposite. Across from the 90 is the hypotenuse, and right next to the angle would be my adjacent. So what I'm looking at is the opposite side and the adjacent, and that's a tangent relationship. So the tangent of 51 should equal the opposite side 8 over the adjacent side of x. Same idea. The tangent of 51 is approximately 1.2348, and that should equal 8 over x. Here's why I like to think of over 1, because 8 times 1 is 8, and then 1.2348 times x is just that times x. So this shows me that I need to divide by the 1.2348 to figure out what x is, and I'm getting that x is equal to 6.5. And that's how I'm going to use sine, cosine, and tangent to answer those types of questions. What I was thinking of with no right angle was this next problem. Without the right angle, you're forced to use the law of sines or law of cosines. So to decide which, you need to look and see if you have pairs. I do have a pair of numbers here. 10 is across from that 38 degrees, and x is across from that 15. So 15 over that angle. Now notice, with the law of sines, I got to do it in the same order. I put the side over the angle and the side over the angle. You can't always put x in the top. It doesn't work that way. So it's called the law of sines if you can come up with this ratio where the side over the angle equals the side over the angle. But since it's called law of sines, you got to remember, it's the side over the sine of its opposite angle should equal the other side over the sine of its opposite angle. So law of sines, I've set this up correctly. I got to understand it's still just a cross multiply. 15 is going to multiply by the sine of 38. And 10 is going to multiply by the sine of x. So I just write that. Now I'm trying to figure out what x is. So the first thing I do is I divide 10 from that side to solve the equation. So I end up getting 15 times the sine of 38 divided by 10. And that should equal the sine of x. So what I'm going to do now is punch all that into my calculator. 15 times the sine of 38, I hit equals, and I end up getting 9.234. But then I'm going to divide that by 10, and I get 0.9234 equals the sine of x, which is good. I need to make sure that this decimal is less than 1 because I can never have a sine of an angle greater than 1. So this is the time where I say, well, if I want the angle, I got to go to the calculator and say, what is the sine inverse of that number, because that will leave me x. So I'm going to do the sine inverse of that 0.9234, and I'm getting 67.4 degrees, which we're just going to round to the nearest degree and say that's a 67-degree angle. And that's what you do when you don't have the right angle. You have to use the law of sines. Number 7, you have a rectangle. You should know that in a rectangle you get 90-degree angles, and you get 90-degree angles in all the corners. You also have parallel sides, so this is alternate interior, 26 degrees. It doesn't matter which triangle you use, because we should know opposite sides are the same. You have two congruent triangles, you're trying to figure out x. I'm going to draw the triangle that's pointing to the right, so it's got x, 26 degrees, and a side length of 24. So this is just like the problems before. I decide what I have. I draw a cross, that would be the opposite side, and the side right next to it would be the adjacent, because remember, across from the 90 is always the hypotenuse. So I have the opposite and adjacent with an angle, that would be the tangent. So the tangent of my 26-degree angle should equal the opposite side x over the adjacent side 24, and now I'm going to solve this. The tangent of 26 is 0.4877, and that should equal x over 24. So again, I'll think of it as over 1. X times 1 is x. So all I have to do is take that 0.4877 multiplied by 24, and I get 11.7 for that missing side. Now, problem number 9. Well, let's do number 8, sorry. Problem number 8, again, I don't see a right angle. I could check to see if it is because I've got 52 degrees here, 24 degrees here. That's a total of 76 degrees. So 180 degrees minus 76 is going to leave me a total of 104 left. So I know, in fact, it is not a right triangle. So I'm going to have to use the law of sines again here, or the law of cosines. So if I'm trying to decide law of sines or law of cosines, I look for pairs. I've got a pair of angles here. It's the side over the sine of its opposite angle should equal a side over the sine of its opposite angle. So I am able to create a proportion here that does not have more than one unknown, x. So I'm going to cross multiply and solve. I'd end up taking the 12 times the sine of 104, and that should equal x times the sine of 24. Well, remember, sine of 24 and sine of 104 are numbers, so I'm going to divide this side by the sine of 24 to get x all by itself. So what I'm left with is 12 times the sine of 104 divided by the sine of 24. So that's what I'm going to type into my calculator. 12 times the sine of 104, which is about 0.97, equals, and then divided by the sine of 24, and I get 28.6. If you're not getting 28.6, make sure you understand how your calculator is doing that and in what order you need to type it in. Now for problem 9. I believe I did give you a right angle over here in the corner. You're just going to have to do more than one operation of trig. For example, if I'm only trying to find from here to here, that length is not in a right triangle, so sine, cosine, and tangent not going to work for me. However, law of sines is not going to work for me either because I only have one angle and one opposite side. So I start the law of sines by saying x over the sine of 31, but now I need another angle and another side measurement. So what I'm going to do is use this right triangle on the left that has a side of 12 and an angle of 35 to figure out what is this hypotenuse. I'm going to call it h because I know it's the hypotenuse. Well, that's a cosine function because 12 is the adjacent and the hypotenuse is h. So it's the cosine of 35 should equal my adjacent side 12 over the hypotenuse of h. So it's going to be over 1, so I get 12 equals the cosine of 35 times h. I would have to divide by the cosine of 35 to get that h by itself. So I get 12 divided by the cosine of 35. So here again, you're seeing me not type it in and get a decimal. If you prefer that, just go ahead and type in the cosine of 35. You'd be working with 0.8191 instead of just the cosine of 35. So when I type this into my calculator, 12 divided by the cosine of 35, I get that hypotenuse is about 14.6. So this length right here is 14.6. Now that would be useful if I knew this angle over here, but I should be able to figure that out. Because if I have 35 degrees and 90 degrees, 35 plus 90 is 125. That leaves me 55 degrees for this angle right here when I subtract them out of 180. But that angle right next to it is a linear pair, so that equals the 125 to make 180. So now I have a 31 degree angle, a 125 degree angle, which is a total of 156. Subtracted from 180 leaves me 24 degrees for this angle. And now I have a relationship. I know it's getting kind of messy, but I've got 14.6, which is across from this 24 degrees. Exactly like the 31 and the x are across from each other, so I'm ready to go with a law of sines. X over the sine of 31 should equal my 14.6 side length over the sine of the 24 degree angle that I figured out. So I have to do two sets of trig. The cosine was to find that missing side length so that I could do the law of sines. So I end up getting x times the sine of 24 equals 14.6 times the sine of 31. So I have to divide by the sine of 24 to get x by itself. So what I'm going to punch into my calculator is 14.6 times the sine of 31 divided by the sine of 24. And when I do that, 14.6 times the sine of 31 equals about 7.5 divided by the sine of 24, and I get 18.48. So we're just going to round to the nearest tenth, so it'd be 18.5 for x.